All right, this is the video for page 3 of lesson 2.1, applications of percents. And this is a mixed practice. It is basically going over the 3 types of problems you saw in the first 2 pages. One where you're finding the part, the other where you're finding the whole, and the other where you're finding the percent. So you just have to read each of the problems and try to figure out which one it's asking for. This is kind of your mixed practice, so you want to go ahead and pause the video, work a problem, unpause, watch the video to just see how you did on it. So this is really a good opportunity for you to get feedback on your understanding of the previous examples. All right, so hopefully you've already worked the first problem, so I'm going to go ahead and start on this. Laptop costs $800. A store charges 8% sales tax. What is the total cost? So in this case, we know the original, right? So once again, when we look at our fraction, we have the part, and then this is either the whole, total, or original value. And so in this case, we know the original. It was 800. And they do an 8% sales tax, so we're going to have to find 8% of 800. Now, what is 8% as a decimal, right? So you can always, and I am seeing some people really struggle when it's a 1-digit decimal like this. So, I mean, I know it's at 8%, sorry, 1-digit percent. I'm seeing a lot of mistakes with those, where I'll see a 0.8, but if I do 8 over 100 as a fraction, and then I convert that to a decimal, it's 0.08. A 0.8 is 80%, not 8%. So when you move the decimal twice, you actually leave a, if I have 8% and I have the decimal here, if I move it twice, there's actually an empty space that you have to fill with the 0. So this is 0.08 times the 800, which I think is $64. Let's check. 0.08 times 800. It is $64. That is the tax. But they want what is the total cost. So I'm going to have to do the 800 plus the 64 to get the total cost. $864. All right, for the next one, a population increased by 376 people. If this was a 12% increase, what was the original population? And there's your keyword. They want you to find the original. This means you're going to divide by the percent. So we're going to take our 376, this is the part, and we're going to divide that by 12%. And so we do 376 divided by 0.12. And, oh, I'm sorry. I have a correction here. This is supposed to be a 5. And the reason it's supposed to be a 5 is because it works nicer. There we go. 3,125. I have to make sure to change that on my notes there for the next time around, so apologize for that. You should have notes reflecting that. Only the first class where I made this mistake should have it, so if you're in a subsequent class after term 2 of this year, it should work fine. So that is going to be 3,125 people. That's the original population. Oh, sorry, I scooted that up. So once again, this should already say 375 on your notes. And so we divide 375 by 0.12. So I'm going to get rid of the percent there, and I'm going to put 0.12. I apologize, I really messed up on that one. All right, there we go. So you take your amount, you divide it by the percent, and that gives you the original value. Let's take a look at the next problem. At Costco, 428 people were asked if they preferred cake or pie. The number of people who answered cake was 153. What percent of people preferred pie? Now you have 2 ways you can approach this problem. We could just go with, and we're looking for the percent, right? So we're creating a fraction. 428, that's your total number of people that were surveyed. 153 are the ones that said they preferred cake. So if I do 153 divided by 428, we get 35 point whatever. That's a horrible fraction, right? We don't have to do all the values here. So 0.35, let's stop at 7. And as a percent, that's 35.7%. Rounded. It's not exact, but it's close enough. Now, what does this 35.7% represent? That's people who preferred cake, because it was based off the 153 people that answered cake. So in order to find the number of people that liked pie, we're going to have to take the 100 and subtract the 35.7%, because then the flip side, assuming that they only had two choices, cake or pie, that means the other, the remaining people that answered the survey answered pie, and that would be 64.3%. So that's the percent of people that said they preferred pie. Now you could do this another way. You could take the 428 and subtract the 153 and say that's the number of people that preferred pie, 275. So you could, I'm going to separate this out, do 275 divided by the 428. And so that's the people that represented, that wanted pie or preferred pie over cake. You could just divide that and get the decimal value, which is 0.64, 0.64. And if I stop here, this 5 rounds this 2 to a 3, which is 64.3%. So you either way will get you that same answer. All right, an employee earned a 5% raise. This increased their salary by $2,400. What was their original salary? So for this problem here, we know the part. Once again, there's your keyword, original. You know that's the denominator that you're looking for. So you're going to take the 2,400 and you're going to divide it by this percent as a decimal. Remember, if it's single digit, you're still moving it twice. That should be 0.05. And so we'll do the 2,400 divided by the 0.05. And 48,000 is going to be the original salary. All right. So for the next problem, a student's grade improved from 72% to 90%. By what percent did the grade increase? All right, so this is kind of an interesting problem, a little bit different than the others. We want to find kind of what percent one is of the other. So it was 72, it went to 90%. So if I do 72 over 90, 72 divided by 90, that's 0.8, huh? So that tells us that 72 is 80% of 90, but does that tell me the percent increase? I don't think it does. Oh, so this one here, I just kind of followed the previous method, but it didn't increase by 80%. So sometimes when we work a problem, we just like follow the process that we've been doing, and then the answer doesn't make sense. Then we have to reread the problem. The grade improved from 72% to 90%. Oh, this isn't a percent. You're not trying to find what percent 72 is of 90. So this method doesn't work. The percent increase, it was 72, it went to 90. This is a subtraction problem. That means it increased by 18%. So we always want to be real careful when we engage in a problem. If we've learned a process, it's real easy to want to jump into that same process that we practiced before. But sometimes that's not what they're asking. So really taking your time to stop and read those questions and make sure that what we're trying to answer or the process we're using really answers the question they're asking for. In this case, the percent increase, well, 72 to 90, that's an increase of 18%. So all I had to do was subtract. There's no multiplication needed here. And the questions were already percents. Number 6, a coat priced at $90 is marked up by 20% before being sold. What is the selling price? So it's at $90. It's marked up 20%. So we actually want to find 20% of 90. So we are going to multiply by 0.2. So we'll do 90 times the 0.20, and we get $18. So $18 is going to be the markup, which we're going to then add to our $90 because they want to know the selling price. So we'll add our 18. That becomes $108. All right. So for this last part, we're going to talk about percent of increase or decrease. And I have an equation here that works for this. So what you're going to do is you're going to take the new value, you're going to divide it by the old value. And then you're going to multiply it by 100. That's going to change it into a percent. And then you're going to subtract 100 from it. And this will tell you whether it's an increase or a decrease. And so this minus 100 really works well. I'll show you how this makes sense. So we'll start with the first one here. A teacher's annual salary is increased from $48,000 to $51,600. So the new salary is $51,600. The old salary is $48,000. Now, I'm going to put in the rest of this formula, and we're going to use our order of operations. Order of operations, there's no parentheses, there's no exponents, multiplication, division from left to right. Division's right here. A fraction bar is divide. So we're going to do 51,600 divided by 48,000. And that's going to give you a 1.075. Then we're going to multiply that by 100. That essentially moves the decimal twice. So that's 107.5 minus 100. And then subtract 100, 7.5. So that means this salary increased 7.5%. So it's a 7.5% increase. So subtracting the 100 takes away the original amount, like the 48,000, because this is 107.5% of the original. So by subtracting the 100, you're taking out the original amount and showing you what percent is left over. All right, let's take a look at another example. Here, a population grew from 8,000 to 9,200. So this is the old, and this is the new. I probably should have done the same thing here. This was the old salary. This is the new salary. So you're going to do the same thing. It is going to be it's going to be 9,200 divided by 8,000 times 100 minus 100. So we'll go ahead and do the math on that. So 9,200 divided by 8,000 gives you 1.15. Then you'll go ahead and multiply by 100. Basically moves the decimal twice. You get 115. And then subtract 100%. That basically removes the original 8,000 from it and tells you what percent was left over, which is 15%. All right, so this winds up being your answer. That was a 15% increase in population. All right, so there's one more video left, so if you'd go ahead and continue on to the last video for page 4.